Hi dear students, welcome to Shakthi digital classes. My name is Ganesh. Today we are going to study the first chapter of mathematics, and that is the number system, which you can see on the screen. Well, when we speak of the numbers, as in general, you have seen many types of numbers, starting with the counting numbers, which are something like this: 1, 2, 3, 4, 5. It goes to infinite numbers, and we know that we call these numbers as natural numbers, isn't it? Exactly. Then can you tell me what are the next type of numbers that you have seen in your previous classes? Yeah, some of them are saying it right. The numbers including all these counting numbers as natural numbers, including 0. Yeah, which I can show you here. Yeah, you can see that include 0 in the natural numbers, so you get another set of numbers, and these are called as whole numbers. Fantastic, isn't it? Yeah. Now, if I include, for the same set, if I include negative of the natural numbers, you know these are the natural numbers. If you take negative of this one, what I mean to say is, yeah, something like this: negative 1, negative 2, and all. These set of numbers, we call them as integers. Right? Fantastic. So now comes the numbers which you have seen something like this, which we read them as 5 by 9, or minus 3 by 1, or 4 by 3, and 1 by 3, and so on. What are such type of numbers are called as? Any guesses? Yeah, some of them said it right. These are numbers whom we call them as rational numbers. So now definitely ask me, sir, what is the definition of rational numbers? So if you see here, these are all the numbers that are the yellow color. They are the numerators, and which is an integer, and denominator is very important, non-zero integer. What do you mean by non-zero integer? Yeah, you are right. You consider any integer, but it should not include 0 in it. Yeah. So the ratio of integers, we call them as rational numbers, and we have an exact definition for that, which says that if p is any integer and q any non-zero integer, then the rational number is defined as p by q, which you can see here. Numerator is integer and denominator is non-zero integer. Well, if p is any integer and q is any non-integer, then p by q is a rational number. Just now we saw that. For example, you can see that 9 by 4, which you do actual division, you get answer as 2.25, or 11 by 3, you get 3.66, and so on. Isn't it? One very important thing here we need to note, students, that is, when you divide 9 by 4, you get answer as 2.25. In the same line, if you divide 11 by 3, you're getting 3.66666, so on. Can you see the difference between these two decimals? Yeah, you got it right. This guy is terminating exactly after 5. But whereas this guy is not terminating, he just keep on going. Isn't it? What I mean to say is, this guy will be 3.6666666, it continuously going. Right? So that's why we call such decimals as terminating, and this we call them as non-terminating and recurring. Now definitely you'll ask me a question, sir, what do you mean by recurring? Yeah, any guesses? Yes, that's again right. Recurring matlab hota hai repeating. So you can see in this particular decimal, I have 3.6666. You can see that there is a one digit which is keep on repeating. What is that number? 6. Yeah, the 6 is a digit which is keep on repeating. So such rational numbers, we call them as non-terminating and recurring. Okay? Yeah. So you know that in a short way, instead of writing 3.6666, we just write as 3.6 and a bar. This bar says that particular digit is repeating. So if you see this one, 4.914, 914, 914, and you can see that something is repeating there. What is that? Yes, you're right. 914 is repeating. So in order to write in a short form, how can I write this one? As Yes, I can write as 4.914 ऊपर होता है बार. I hope you are getting me right now. So yeah, here I have some list of rational numbers written. In this one, you should tell me which is terminating, which is recurring, which is not. You see the first one, the rational number what I have here is 0.048 bar. Okay, is it a rational number? The question says here we have to identify among these which are actually rational numbers. Now definitely ask me a question, sir, what exactly rational number? You said earlier the definition as any number which is written in the form of p by q, where p and q are integers and particularly q should not be equal to 0. And now sir, you are giving me some decimal numbers. How to say that? Yeah, you are right. That's the right question. Whenever the decimal is given, whenever the decimal number is given, how to check for rational number is very simple. First thing, it should be terminating. I hope you're getting me. It should be terminating, or it should be non-terminating but recurring. So these are two conditions we have. The first condition is it should be terminating, then I can call it as a rational number, or it should be non-terminating plus recurring. Such numbers are called rational numbers. So let's see the first one, which is 0.048 bar. It is non-terminating and recurring. Matlab, this is a rational number. Yes or no? Yeah, you're right. For the second one, yeah, you can see this one. This guy, 4.914 bar. Definitely, it is. Yeah, you're right. It is non-terminating but recurring. So this is also rational number. This is obviously terminating, so rational number hoga. And what about this? This is very, very important. When you see this decimal, dear students, when you see this decimal number, can you see, is there anything repeating here? Is there anything recurring here? If I closely observe this guy, it is 0.01231254785. Nowhere I can see something is repeating, isn't it? So it is non-terminating but non-recurring. So such numbers are not rational numbers. You got my point? Exactly. So if you see here, so this is non-terminating and non-recurring, hence it is not a rational number. Can you guess the remaining 4? I'll give you 10 seconds. Let me see who will give me the right answers in the comment section. I hope you have solved it. Let me show you the answer for you. This one is non-terminating and non-recurring, hence it is not a rational number. This is exactly the same, non-terminating, non-recurring, hence it is not a rational number. And the same case here also. And the last one is yes, it is non-terminating but it is recurring. इसलिए क्या होता है? This is a rational number, right? Yeah, that's great. Now you may ask me a question, sir, if it is not a rational number, then what type of a number is this? If it is not rational, then what type of number is this? What can we call it as? Okay, in that case, such numbers, particularly those numbers which are non-terminating and, very important, non-terminating and not repeating, such numbers we call them as irrational numbers. Did you hear me? Yes, it's right. They're called as irrational number, opposite of rational numbers. Exactly, these are numbers which we call them as irrational numbers. Great. So yeah, you can see the definition also. The numbers whose decimal form is non-terminating and non-recurring are called irrational numbers. Okay, let's see something here. Let's find square root of numbers that are not perfect squares. Now you'll ask me a question, sir, what is a perfect square? Okay, yeah, it goes like this. If I ask you this question, what is square root of 2? What is square root of 2? Some are saying, sir, answer is 1. No, no, that's not right. If I ask you what is square root of 4, then you'll say answer is 2. Absolutely correct. Okay, let me write it for you. Okay, if I ask you if I ask you what is square root of 4, so you say answer as 2, isn't it? If I ask you what is square root of 9, then you say answer is 3. These numbers are called perfect square numbers because for them you have the roots that you have studied in 8th standard, right? But if I ask you what is square root of 2, do you know the answer for this one? No, not at all, because you know that 2 is not a perfect square, isn't it? Yes or no? Exactly. So then how to find the value of these things? For time being, I'll give the values of these numbers. Later we'll see how to get those values. Okay, so the root 2 का exact value होता है as 1.414213562373. Oh my god, that's a big number. Yes or no? Now right now don't ask me how we got that. Let's not talk about it. You just see, observe the expansion, observe the decimal form. You just tell me, is it rational or irrational? Think and tell me, is it rational or irrational? Yes, you are right. What you assumed is absolutely correct. It is irrational. Why? Because, sir, this is non-terminating as well as not repeating. None of the digits, there is no pattern which is repeating. That's why it is an irrational number. How about the next one? Root 3. See the number, see the decimal. Is it? Yes, it is not. Exactly. Root 5, root 6, and so on. So these all are the numbers who are irrational numbers. Great. So now, so far what all we studied, I'll just have a quick recap of all those things. So we studied natural numbers, whole numbers, integers, and we call all of these numbers as rational numbers, integers, rational numbers, which are the ratio of two integers provided the denominator is not equal to 0, and terminating and non-terminating, recurring, they all come under rational numbers. And irrational numbers are non-terminating and non-recurring. If I call them as a big set called as real numbers. So real number, generally I call them as the head of the family of the number system as of now. Okay, yeah, so in real numbers we have two things basically. One is rational and irrational. Rational के नीचे we have all the set of numbers. Right? Fantastic. I hope you have noted down these things. The next concept will start. Hi dear students, welcome back to Shakthi Digital Learning. Let's continue from the point where we stopped in the last class. Yeah, let's start with the first exercise of the chapter number systems. The chapter exercise number is 1.1. Let's take the first question. As you can see that the question says, is 0 a rational number? And can you write it in the form of p by q, where p and q are integers and q is not equal to 0? Well, I'll wait for 30 seconds to get your answers. First thing is very simple. You have to tell me whether 0 a rational number or not. Yes or no? Very good. Some of you said it absolutely correct. Yes, 0 is a rational number. But why and how? How 0 is a rational number? Can we express in the form of p by q? Yes, definitely. Yes. You can see that 0 is a rational number because 0 can be written in any of the following ways. I can write 0 as 0 by 1, isn't it? In fact, you all know that you can write any integer. For example, if I say, if I say, see, I can write 0 as 0 by minus 2 also, and 0 as 0 by 3, yes, 0 by minus 7, anything in fact. So, thus 0 can be written as p by q, where p is 0 and q is any non-zero integer. This is very important. Q is any non-zero integer, right? Even if you give me any integer, let's say 4 is an integer, right? Is 4 a rational number? Yes, definitely, because you can write 4 as 4 by 1, isn't it? You take any negative integers, let's say if you take minus 2, can I say it's a rational number? Yes, definitely. Why, sir? Because we can write minus 2 as minus 2 divided by 1, where p will be minus 2, q will be 1. Hence, it is a rational number. Got it? Fantastic. Let's go. You can pause the video to note down the solution. I'll go to the next question. Yeah. This is a very, very important point we all need to note. Okay, what it says. To find n rational numbers between any two rational numbers, we will multiply both the numbers, both the numbers in the sense, both the numerator as well as denominator by n plus 1. Okay, I think this concept you studied in the previous year also, maybe in 8th standard, but there we approached in a different way when we write rational numbers, rational numbers between any two numbers in fact. Okay, yeah, let's see how to use this guy. I'll take the second question of the same exercise 1.1. The question says that we need to find 6 rational numbers between 3 and 4. Yes, true. In the number line, you all know that 0 will be in the between, and the left side you will be having all these positive integers, and the right side will be having negative integers. Yes. Now they are asking you to write 6 rational numbers between 3 and 4. How to do that? Some are saying, sir, can we say 3.1, 3.2, 3.3? Yes, of course you can do that. But 3.1, 3.2, 3.3, they all are decimal numbers. And what we are exactly expecting is the fractional form of that, in the form of p by q. So for that, just now we had the note thing, we will use that guy. Okay, so they said 6 rational numbers. Since we require 6 rational numbers between 3 and 4, so we write, to find 6 rational numbers between any two rational numbers, we multiply both the numbers. When I say both the numbers, I mean numerator and denominator. So you can see that if I multiply, so they want 6 rational numbers. So in the previous slide, we saw that n plus 1 divided by n plus 1. Right? Now, n का मतलब क्या है? N का मतलब है 6 in this case. So this is why 6 plus 1 by 6 plus 1, which is 7 by 7. Right? So what I'm going to do is, I'll take the number 3 and I can write 3 as 3 by 1. Just now we got to know that. Yes or no? Yes. So 3 is 3 by 1, and for this 3 by 1, what I will do is, I'll multiply 7 and divide by 7. Yeah. So now you can see that 3 into 7 is 21, and 1 into 7 is again 7. And similarly, we'll go for the 4 also. We can write 4 as 4 by 1, and again we'll multiply for this guy 7 and 7. So you get 4 into 7 is 28, and 1 into 7 is 7. So now the numbers 3 and 4 can be written as 21 by 7, 28 by 7. If you know, if you use your common sense, you can say, sir, if I cancel 7 ones are 7 threes, I get 3 only. 7 ones are 7 fours are 4 only, isn't it? Yeah. So now you can see that between 21 and 28, these numbers exist: 22, 23, 24, 25, 26, 27. Isn't it? Yeah. So they said 6 rational numbers. If you observe carefully, you have 1, 2, 3, 4, 5, 6. Exactly 6 numbers between 21 and 28. So अभी हम क्या करेंगे? What we'll do now is, we'll write 21 by 7. उसके बाद में हम will write 22 by 7, 23 by 7, 24 by 7 and so on. Isn't it? So if you see carefully, A था हमारा 3 and this was our 4. This number is 3, this number is 4. In between these two numbers, we wrote 6 rational numbers in the form of P by Q. Right? Yes, we wrote this one. And hence the 6 rational numbers between 3 and 4 are these numbers. I hope you got it. It's very simple, isn't it? Only thing is, you need to check how many rational number you want between any two numbers. I mean to say, you need to know the value of n. अगर n मिल गया तो बाकी सब आसान है. Yes, please pause the video to note down the things and I'll go back to the next question. Yeah. Let's go to the next question. The question is again similar to what we saw in the earlier question. Question says that find 5 rational numbers between 3 by 5 and 4 by 5. So we'll do one thing. You can pause the video right now and try to do it by yourself. Once you're done, again start the video and see your solution. Right? So please pause the video to start your solution. Well, let me continue now. Let me continue. You can see that we need to write 5 rational numbers. Matlab the value of n is 5. Right? Okay. So see, the same thing I'm writing here. To find 5 rational numbers between any two rational numbers, we multiply both numerator and denominator by 6. How we got 6? Yes, 5 plus 1. 6 by 6. Yes, I'll write 3 by 5 here and 3 by 5. I'll multiply with 6 and 6. So 3 into 6 is going to be 18. Yes or no? Absolutely. So this is 18 and 5 into 6 is 30. Similarly, 4 by 5. I can write as 4 by 5 multiplied by 6 into 6. 6 by 6, sorry. So this 4 into 6 is 24 and 5 into 6 is 30. अभी हमारे पास क्या है? Now we have 3 by 5 as 18 by 30. 4 by 5 as 24 by 30. So let me write those numbers here. Between 18 and 24, you got these many integers. I hope all of you got the same thing in your book, isn't it? Fantastic. You guys are doing great. So now, so this is 18 by 30. Yeah. And 19 by 30, 21 by 30, 22 by 30, 23 by 30, 24 by 30. So in दोनों के बीच में we got these 5 rational numbers. Yeah. Tell me honestly how many of you got this answer right in the comment section. Okay? Great. Well, okay, those who didn't get the solution, please pause the video and note down the solution as it is. Yeah, I'll go to the next question. Yes. Exercise 1.1 again with the question number 4 says that the question says that state whether the following statements are true or false and give your answers or justification also. If you're saying true, why true? If you're saying false, why false? Okay? The first question is this. Every natural number is a whole number. Please pause the video and write your answer in the comment section, please. Every natural number is a whole number. I'll think, what are actual natural numbers? Oh, natural numbers are 1, 2, 3, 4, 5, 6 and so on. Isn't it? And what are whole numbers? Whole numbers are those numbers which starts from 0. 0, 1, 2, 3, 4. Right? Oh, in that case, if I take any natural number, let's say if I take 1, 1 is a natural number as well as a whole number. Yes or no? Yes, you're right. Matlab the given statement is absolutely true. Yeah, I can see that it's true because every natural number is the collection of whole number. Yeah. Question number 2. Every integer is a whole number. Okay. I'll wait for again 1 second. Let me think and give me the answer. True or false? Every integer is a whole number. Yes, you are right. Answer is false because you can see that -3, -2, they are integers but they are not whole numbers. Isn't it? Very good. Let's go to the next one. every rational number is a whole number. What do you think? Every rational number is a whole number. Is it true, false, true, false? Yes. Again, you are right. Answer is false, because you can see that 1 by 2, 3 by 4, these all are rational numbers, but they are not whole numbers. Alright, please pause the video to note it down. Yeah, again same questions, same type of questions, true or false. Let's see. Sorry, so exercise number 1.2. From 1.2 you are doing the first question. Now, every irrational number is a real number. What do you think? First you will ask me what are irrational number. In the previous video we have seen what is the irrational number. The numbers which cannot be written in the form of p by q, or else you can say the decimals which are non-terminating and non-recurring. Are you with me? Irrational matlab non-terminating and non-recurring. Right? So now the question is, every irrational number is a real number. Now definitely you'll ask me a question, sir, what are real numbers, sir? As of now we have studied only natural number, whole number, integers, उसके बाद में rational number, irrational number. What are these real numbers? Yes, we wrote in the chart in the previous video, right? The set of all these numbers. Right now what I said, natural number, whole number, सब मिला के जो बड़ा वाला set मिलेगा, that set is called a real number. So definitely for this question your answer should be true or false. Yes, answer should be true. Right? Very good. Oh yeah, let's see this question. Every point on the number line is of the form root m, where m is a natural number. Take your time, pause the video for 2 seconds and check whether your answer is true or false. Yes, some of them got it wrong, some of them got confused also, couldn't able to get the answer. Don't worry, I'll tell you the answer. Answer is actually, if you see carefully, this is the number line we have here, and this is 0, 1, 2, 3, and this is the negative integers, and you have root 2 here, or let's say root 3 here, isn't it? Yeah. So the answer is false. So numbers of the type, let's say -5, -4, half, and -7 by 8 also lie on the number line, but which cannot be expressed as a root of m, where m is a natural number, isn't it? Because you can never get -5 as the answer if you want to write into the form of root of m, isn't it? Very good. Every real number is an irrational number. What do you think? Is the right answer? No. Yes, you are right. Answer is false. Right? Yeah. You can pause the video to note down the solutions. Yeah. I'll go to the next question. Again, exercise 1.2 itself. Okay. Let's read the question carefully. Are the square roots of all positive integers irrational? Okay, let us read the question again. Are the square roots of all positive integers irrational? No way at all. Because if I take square root of 4, my answer is 2. And 2 is not irrational. 2 is a rational number. Yes or no? Absolutely. So answer is no. Square roots of all positive integers are not irrational, because if I take the example of these numbers, for example root 4, इसका answer है 2, which can be written as 2 by 1. It's a rational number, right? Similarly root 9, root 16, root 25, and so on. And yes, please pause the video to note down the solution. Well, let's continue with the next questions, dear students. Yeah. So if you see that, let's see the questions of exercise 1.3. Well, the first question is, write the following in a decimal form and say what kind of a decimal expansion each has. Okay, let's take the first question. Yeah, first one is 36 by 100. Very easy, isn't it? Yeah, please give an answer in the comment section. Yes, you're right. You're right. 36 by 100 can be written as 3, what is that? 0.36, isn't it? Because you all know that whenever you have two digits in the denominator with a 1, that is 100, I mean to say, you have to keep a decimal point just after the two digits, isn't it? That's 0.36 and it is a terminating decimal. I just want that, whether it's a terminating or non-terminating. That's all I want. Well, next one is 1 by 11. Please, you can pause the video and solve by yourself and write the decimal form. I'll wait for 2 minutes. Yes, you're right. You're right. Some of them got it right. Yeah, some of them may be finding difficult how to divide this guy. Okay, let me help you that. You know that 1 can also be written as 1.000 and 1 is less than 11. These are all simple things. You already know it. But still, for some students, they might find it difficult. For them, let's help. Isn't it? Right. So if I divide, so if I see 1 is less than 11, isn't it? So what we do? We put 0 and a decimal point. Then we say 10. Oh, 10. 10 is again smaller than 11, right? Yes. So we'll put 1 0 and we'll take it as 100. And if I divide 100 by 11, which is 99, 11 nines are 99. And if I subtract this, I'll be getting 1 and I'll take this 0 down. One more 0 because 10 is less than 11. This 0 also I'll take it down. So it is 100 and yeah, 11 nines are 99. Again the remainder is 1. The same thing actually continues here, isn't it? Yeah, right. So some of them already got the answer actually. So this comes out to be 0.090909. And yes, now tell me what kind of a decimal is this? Yes, you're right. This is actually non-terminating, but it is recurring. What is recurring? 0.09. 09 is recurring. What do you mean recurring? Matlab repeating. Simple words, right? Great. Yeah. Oh, what kind of a fraction is this one? Yes, this is a mixed fraction, right? And how to convert mixed fraction into improper fraction? You all know it. Yes, you can write this as 4 integer 1 by 8. You will multiply 8 and 4, which is 32. 32 plus 1, 33. Yes, right. Yes, you are right. It is 33 by 8. Now we'll go for the division, the actual division. Yes, some of them actually got the answer. Even I showed the answer. What is the answer? Answer is 4.125. Now tell me, is this terminating or non-terminating? Sir, it's obvious. It is terminating. Fantastic. Exercise 1.3, fourth question, 2 by 11. Pause the video, do it, write the answer in the comment section, right? Yeah, I'll write it. I'll go for this division. I'll just go for this division. 2 11 by 2. Again, this is the same thing. Just in the previous question, we did it. Yes, since okay, let me start from the beginning. 2 is smaller than 11. Okay. So then we put a decimal 0 with a 0 point. We'll take 20. 20 is bigger than 11. So we write 11 ones are 11. So 20 minus 11 will be 9. Then we take this down. It will become 90. Now again 90 in the 11's table. 11 8s are right. Yes. So 98. 88. Sorry. Yeah. This thing continues. And your answer will be 0.1818. Now tell me, is it terminating, non-terminating? Yes, it is non-terminating, but also not recurring. 1818, you can see that 18 is recurring, right? Yeah. Let's see question number 7. Oh, looks a bit a lengthy question, but we'll try to decode it properly. You know that, what we know? You know that 1 by 7 is equals to 0.142857. Oh, that's a pretty big recurring decimal, isn't it? Yes. So, you know that 1 by 7 is this guy. Can you predict what are the decimal expansions of all these numbers? That too without actually doing the log division. If so, how? You can do one thing, you can pause the video, try to read the question by yourself and try to attempt the solution. Okay, you can pause the video. I'll continue anyway. They have given me 1 by 7, right? So decimals which are repetitions of 1 4 this one, for example, you can see students that the 2 by 7, the rational number is 2 by 7. I can write 2 by 7 as 2 into 1 by 7, right? Obviously I can do that, because if you see, this is 2 ones are 2, 2 by 7, same thing, right? Why I'm writing it? Because this 1 by 7, that rational number, uska answer is already known to me, isn't it? It is given in the question, right? 1 by 7 is given as this number. So what I'll do now, I'll take that 1 by 7, I'll multiply with the 2. Okay. And I hope you all know how to multiply, right? But still, I'll tell you. 2 sevens are 14 with the 1 carry. 2 fives are 10. And yes, let me not waste time on this one. This is a very easy calculation. Yes. So that's how, if you multiply these two, this will be your answer. You don't need to do the long division method by doing this 2 by 7 thing. You can directly write the answer, right? Yes. Next one is this 3 by 7. Similarly, the same answer goes, the same process goes here. You can see that I have multiplied already. You got this, right? I hope you got the answer for this one, right? Very good. Let's go for the next one. A similar way, 4 by 7, which you can write as 4 into 1 by 7. And yes, if you multiply this guy, who is this guy? This guy is 1 by 7, right? And you please multiply it. And when you multiply, you get something like this, right? This is the answer for that. Now 5 into 1 by 7, you can please pause the video and do it by yourself, right? Yeah, that's the answer. Same goes for 6 by 7 also. You can verify your answer. Please pause the video. Do not copy from what is there on the screen, which is not going to help you anyway. I want you to really pause the video and do it by yourself. Okay, great. And that's the answer for you. Okay, yeah, let's pause the video here. Okay, dear students, let's continue with the next topic, which is very, very important as exam point of view, which will be asked for 3 marks in the exam. Well, see, the question is like this. Express just a second. Yeah, express let's say 0.666666 in P by Q form. In P by Q form. Okay, matlab they have given you non-terminating but recurring decimal, and they expect you to write in the form of P by Q. Right? If I ask you a simple question like this, if I ask you, I have a terminating decimal like this, 1.2, can you please help me in writing in the P by Q form? Yes, some of you they say, it's so easy, sir. What you will do is, you write 1 by 2, you multiply 10 and divide also by 10. Isn't it? If I do that, this gives me answer as 12 and this is 10. So I expressed the terminating decimal 1.2 in the form of P by Q, something like this, 12 by 10. This is easy, isn't it? But their question is 0.66666, non-terminating but recurring, how to express in the form of P by Q. So the process goes like this. What I'll do is, let me consider this guy as, let x as 0.6666 so on, and let's call this as equation number 1. Okay, now what I'll do is I will multiply 10 on both the sides. What I mean by both the sides, I'll multiply in the left hand side as well as in the right hand side. If I multiply 10 on the left hand side, this will be 10x, and if I multiply 10 for this guy, you gotta be careful when you're multiplying with 10, this decimal point shift this side, because you're multiplying with 10. 10 has one zero, one decimal point, you have to shift that side. So it is like this, 6.6666 so on. And let's call this as equation number 2. Now I have two equations with me, with whom I have to play now. So what I'll do like this. Subtract 1 from 2. Sir, how to subtract two equations, sir? We know how to subtract two numbers. But how to subtract two equations? That's again very easy. What we do is we subtract LHS on both the sides and RHS on both the sides. What I mean that this is my LHS 10x and this is my LHS in the first equation. So I'll just subtract them. 10x minus x is equals to, I subtracted these two. Now I'll subtract the RHS part, which is 6.6666 so on minus 0.6666 so on. So now this is 9x is equals to, you know subtraction, yes, right. So if you subtract, this decimal part will go, you'll be just left with 6. Now this is x is equal to 6 divided by 9, or you can say x as 2 by 3. And what was your x? What was x? X was 0.6666 so on, so which we wrote in the form of p by q as 2 by 3. Isn't it easy? Now many students ask me this question saying that, sir, why you multiplied with 10 on the both sides? How will I get to know that? That's a very good question. That's a very good question, isn't it? Yeah, for that I'll be giving the answer in the next question. So please pause the video to note it down. Well, let's take the one more question where you'll understand why I actually multiplied 10 on both the sides. Okay, let's take this question. Let's say the number is 0.232323 so on, or I would say it as 0.23 के ऊपर है एक बार. Now we have to convert this decimal into a fractional form. Okay, so again I'll start the same, the method is the same, the process is the same, but see where things get changed. Okay, yeah. So let's start with this. Let x is equals to 0.2323 and so on. Okay, I will now multiply by 100 on both sides. Okay, now definitely you will ask me a question, sir, in the previous question you actually multiplied by 10, now why you are multiplying with 100? How we will come to know that? That's very simple. You just need to see how many digits are actually repeating, how many digits are actually recurring. If one digit is recurring, as in the previous question, multiply by 10 on both the sides. If two digits are recurring, then multiply 100. If three digits are repeating, multiply by 1000. As simple as that. Okay? Yeah. So if I multiply by 100 on both the sides, so this is 100x is equals to 23.2323 and so on. Let's call this as equation number 2. Yeah, so again same as the previous question. So what we'll do, subtracting, we'll write subtracting equation 1 from 2. So now 100x minus 10 just x This is left hand side subtraction of both the equations, and this is 23.2323 so on minus 0.2323 and so on. Okay, so this is basically 99x is equals to, this will be just a 23, and this is x is equal to 23 by 99. Okay, I think further we can't simplify because 23 itself is a prime number. So that means, what was the x value? X was basically 0.23 bar. So which we wrote it as 23 by 19. Right? This is a very, very important question. Please pause the video to note it down.